Today's problem is called house robber. And what is this problem? You're a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed, and only constraint stopping you from robbing each of them is that adjacent houses have security system connected, and it will automatically contact the police if two adjacent houses were broken into on the same night. Given a list of non-negative integers representing the amount of money of each house, determine the maximum amount of money you can rob tonight without alerting the police. So problem is actually, the story is quite awesome, but the problem is given an array. You have to find the maximum sum you can get so that you don't choose adjacent elements. So this thing, right? Adjacent houses are security, so it means that you can't choose adjacent numbers. So let's just look at this array 1 2 3 1 and try to do something. So there are 4 elements. So if you choose first one, you can't choose second one, then you will choose third one. So that will be 4. So let's say you don't choose, or you can choose 1 and 1, right? So 4 is maximum till now. Suppose you start with 2, you can't choose 3 and you can't choose this one, so you choose this one, which is 3. If you start with this 3, you can only choose this one, which we have already seen, and if you start with this one, you can either choose 2 or 1, which will be less than 4. So the answer is 1 and 3, which will give you 4. Similarly, in this case, you can see if you choose 2 and 9 and 1, it will give you 12, and that is the maximum, right? So that's it. We have to find the maximum sum without selecting adjacent elements. So I will be using a DP for this. So let's see how we can write that DP. So let's handle some common cases. Let's handle some base cases first. If n is equal to 1, alright, so if it is only 1, then there is no adjacent adjacent house, then we can just return that. Basically we are free to use that house. And if it is equal to 2, then you can only take 1, and which one will you take? You will take the max one. Right, so this can be handled easy. And now also we need to check if there are no houses at all. What do we return here? We return 0. Now let's make our DP, and let's call this DP max till. Max till, let's say max till, or let's just call max till. And so what is max till? Max till I will be max sum you can get till I, right? So this is one, and then we will see how we can use this DP. So DP of 0. So if you have to rob house till 0, then you can only rob 0 or not rob it. It's better to rob it because the numbers are non-negative. Then similarly for DP 1, you can rob first 2 houses, then you would want to choose maximum of those. Right. Now we can populate the remaining part of the DP, which is from 2 till n minus 1. Right. So what will be the DP? What will be the possible choices when I am coming at house number I? Steal, don't steal. So if I don't steal, that means that I can't add any value here. I can't add any value here, so it will be basically equal to what it previously was. So let's write this above because I'll be modifying DPI. Right, so if I don't steal, so it doesn't matter which way you write, but you'll have to just, okay. So if you don't steal, then the value here, and my DP is called max till I, will be equal to max till I minus 1. Why? Because at ith position I'm not adding any value, so it will be equal to the previous value. But if I do steal, now it will be max of current value. But if you do steal, right, if you do steal, then you add value how much, which is nums of n. So you are adding this much value, but now you can't use the previous one, so you use previous to that, right? So something like that. So this is the simple DP which you want to do, and then you return what is the max till last index. So this should work. Let's see. Let's read one. And second test case, I'll try to submit it. So this works. So this is our DB which we used to solve this question, and hope it was helpful. Thank you.